Hey, this is Joe at Gray Bench Electronics. If you have been enjoying the tube amp build series, thank you, welcome back. In the last episode, we completed assembly of the tube amplifier. Here it is right here. So the next step is testing and applying power. So that's a multi-step process for me. We're gonna start by checking over the entire amplifier, all the connections against the schematic, make sure everything is connected to where it's supposed to be and no things are connected where they're not supposed to be. After that, we'll actually start applying power to the amplifier. I have some specialized tools I use that allow me to do that application slowly and carefully, so as to not destroy any or damage any components. So let's get started right away and have a look at the amplifier up close, and we'll talk about checks I do before power. All right, so the amplifier is built. The next step for me is going through the entire amplifier, making sure everything is connected where it's supposed to be. And this is in order to avoid any mistakes or find mistakes early before power is applied. Always better to find them then than potentially damaging or risking damage to a component after applying the power. So this is an important step, in my opinion. It is a bit time consuming and tedious. So I did do it off camera, but basically I just take the schematic here, go through each connection, highlighting as I go, making sure every connection is where I want them to be. So once I'm comfortable and certain that all my connections are correct, and if there's any mistakes in there, they are probably not catastrophic ones. Now we are ready to actually start applying power to the amplifier. And like I said in the intro, I have a couple specialized tools that help me do that in a safe and controlled way. All right, so here are the three specialized tools I use when powering up an amplifier for the first time. I'm not going to go super in-depth on each one. There are some great videos out there. I recommend you check them out. But going in order here, we have a bulb limiter, we have a Variac with a digital multimeter attached, and a handheld digital multimeter. So the bulb limiter, as the name implies, it limits the amount of current that can go through the amplifier. This is a 150 watt bulb, which is about it's about like an amp and a quarter at 120 volts. So that's low enough that it will prevent any, or ideally prevent any catastrophic damage to the amplifier if there's a dead short. That's really what this is testing for, is if there's any shorts in the amplifier, so that damage isn't done to any expensive components like transformers or electrolytic, filter capacitors. The Variac is a type of auto transformer. It allows you to vary the AC voltage that's coming out of the output jack here. That's where the name comes from, variable AC, Variac. And I can wind this screw on top here to go anywhere from 0 up to even past 120 volts. This one goes to 130 volts. And then this little readout here tells me the output voltage and the power draw of the amplifier in real time. And of course, the multimeter goes without saying. This is a crucial tool to be able to check voltages at different points in the amplifier to see how the amplifier is running. We'll also use the multimeter to measure the voltage that is developing across the current sense resistors for the output tubes. That'll tell us how much current is going through each output tube, which will allow us to adjust the bias for ideal operating conditions. All right, so we're ready to perform our first application of power to the amplifier. I do want to take a second to say that it should be obvious to you that we're applying voltage to a tube amplifier which has very high voltage in it. You want to make sure you know what you're doing while you do this, because there is a significant danger of electric shock, which can seriously hurt you or kill you. And any work you do is at your own risk. Please be careful. That being said, we have some stuff hooked up here. This first procedure, we are just going to check for AC voltage inside the amplifier. So let's get that going. Oh, also, I didn't mention when we looked at the Variac before, but the Variac has another important feature, which is that it'll allow us to slowly apply AC voltage, which when the rectifier is in there, it will allow us to slowly apply DC voltage to the capacitors, which allows us to form the filter capacitors. Filter capacitors want to be formed. They want to see DC voltage increase slowly over time. That way the components inside the capacitor can get acclimated to the high DC voltage. I don't know the specifics of this, but basically it's supposed to extend the lifetime of the tube, or the capacitor. So let's click some stuff on. Amplifier power is on. It's going to come up here to about half voltage, 60 volts, and we will check inside the amplifier. So this first probe is going to be the high tension going into the fuse. 220 volts, sounds about right. The next probe here is the bias supply, 2 volts. This is one side of the high voltage supply, 220. Here's the other side, 221. Okay. And the 6 volt, 6.3 volt winding for the tube heaters. There's 1.7 there and 1.7 there. Okay, so that's all the points of AC voltage in the amp for half. Let's go right up to 120 volts now. You can hear the transformers humming a little bit. 438, 438, 33 volts for bias supply. These should also be 430 something, yep. 3.3 on one side, 3.4. Okay, good. All right, so we're at the next step of powering up the amplifier. We're ready to insert the rectifier tube. I've confirmed that all the AC voltages are what I would expect. So here is our rectifier tube. This is a GZ34 or 5AR4. Mark, I'll pop this in into the amp. All right, so we got our GZ34 connected. I have my probe on the first stage after the filter choke. So what we're doing here, like I said, is we're going to form up the caps. And that means we're going to incrementally increase our AC voltage input to the amplifier to allow the capacitors to slowly see more and more DC voltage. However, now usually I do it in steps of 10 volts. I'll do 20 volts, 30 volts, 40 volts, and put a couple minutes in between. But I skipped 10 volts because 10 volts isn't really enough to get the heaters going for the GZ34, and also every tube's different, so maybe even 20 volts isn't. We're going to see what happens here. Their first like 100 or 2 volts is hard to control for a tube rectified amp because you're going to eventually give enough power to the filament in the rectifier such that it warms up and starts giving off electrons, which it's hard to control that for the lower voltages to like slowly increase for forming. It's really into like 60 to 120 volts AC input where we have more control over that. Yeah, see here, like we're just not creating enough heat on the cathode to really do anything in that rectifier. All right, I got 30 volts on the AC input. Hopefully we're going to start seeing some power come through here. Yeah, it looks like we're climbing a little bit now. So we've just started to warm up the cathode of the rectifier tube to start making some DC voltage. Our current draw is still minimal. We're at 60 milliamps, which is good. All right, so we're going to leave it here on 30 volts. It's probably going to climb up, I don't know, maybe in the like tens, like 40, 50, 60, somewhere voltage in there. And then after a couple minutes, we'll move up to 40 volts. All right, so it's been a couple minutes. You can see the voltage climbed a little higher than I was expecting. This is what I was talking about, where it's hard to control for this low voltage when forming the capacitors if you're doing it with like a tube rectified power supply. If you really wanted to get specific about forming the capacitors, you could do it on like a separate high voltage supply where you have very fine control over how much DC is being applied. I don't worry about it that much. Back in the old day when they built these amps, they just flip the switch and say, you know, good luck. But we're ready to start moving up to 40 volts here, so let's do that. You're going to start to see that power climb again. So we're applying more voltage, more input voltage, AC voltage now, and that's warming up that cathode, allowing more electrons to flow to the plate, which is allowing greater DC voltage to develop through the amp, and as a result, our DC is climbing. So again, we're going to let this sit at 40 volts for a couple minutes and then slowly form up the capacitor over time. I'm going to go through this process probably without talking each stage because it's boring. We're just going to keep climbing up through the DC voltage in the amplifier until we're formed up. All right, so we're at 80 volts or 82 volts now. We got 404 volts coming out of our rectifier after actually rectifier then filter choke. So I wanted to stop here for a second because you want to be careful here. We have no tubes in the amplifier, which means there's nothing loading down or pulling down the voltage drawing current on the power supply. And we're only at 80 volts on the wall, but we got 400 volts of DC. Now, on my last node in this amplifier, I have a 22 microfarad cap that is rated for 450 volts. Now, when the amplifier is fully up and running with all the tubes in, that stage is not going to see 450 volts. It's going to see about 260 volts. However, right now, it's seeing the full voltage of that first stage. There's nothing loading down the power supply. So I can't go much higher without exceeding the DC voltage rating of that last cap. The can capacitors are rated for 500 volts, so I also can't go much past even 450 for the same reasons. So just note when you're, don't just slam your, another good reason to use Variac, I guess is the point, is if I applied full voltage right now, eventually this amp would come up to higher than the DC rating, definitely of that last capacitor, but also of the, very likely of the other can capacitors. So I might push it up to 90 here, just see if we get up to that 450. If it looks like it's going, then I'm going to stop. And we will complete the last parts of the forming of the capacitors as we're testing the amplifier with tubes in it. All right, so there is 90 volts. And looks like we're going to sit just under the 450 volts. So that's as far as I'm going to push the forming of the capacitors for now. So next step is we are going to throw some preamp tubes in the amplifier and check some voltages. Let's do that. So here are our preamp tubes. We have two of these 7247 tubes, which is it's half a high mu triode, half a high current triode, I believe. So we got two of those, and we got two standard 12AX7. These are ECC 83s. That's a tongue SRAM. This is a Toshiba 12AX7, and the other 7247. So let's pop those in the amplifier. Let's wind this back down. Power's on. 0 volts. Flip that on. So we're going to expect to see more current draw now because we have four preamp tubes, each drawing 300 milliamps per tube for their heaters. That's of course on the secondary side. It's not going to equate to that much on the primary, but we are expecting to see some more current draw now because we have more tube filaments. So as expected, we're already drawing more current, drawing 140 milliamps on the primary side. All right, pretty much leveled out now. We have 59 volts on the AC input. We have a current draw of 160 milliamps on the primary side, wall side. Currently have 162 volts that's on the plate of the second gain stage. So 160 volts right here on pin 1. Let's check some cathodes. So should have, I don't know, a little bit here. Yep, okay. So voltage developing across the cathode means we have current flowing through the tube. And we'll check this cathode here as well. Yep. So all voltages look about what we'd expect. So we're going to clip back on to our first spot and keep bringing up the voltage. Actually, we're going to move that. We're going to come over here to our power supply now because I want to see. I'm going to come right here. So this is on the last stage. This is on the 450 volt cap. There is 120 volts on the Variac. Keep in mind we are going through the bulb limiter, so that's going to affect what we're seeing here. Let's see. So here's V1 plate, 235. It's fine. Let's see some voltages over here. 435. Okay. Yep. Okay. Cool. So we're not forming any more of the caps, and not, at least not with the bulb limiter in here. So even at wall voltage with the bulb limiter. So that's fine, and it's only going to go down when we put input tubes. So right now we just have the preamp tubes in. We're checking our voltages. Want to make sure we see the voltages we want to see. All right. So once again, we've powered down the amp. I checked the voltages. They all look good. What I was expecting. So we're ready to put in output tubes. This is the final stage of inserting tubes into the amplifier and checking voltages. But for this stage, it's very important to remember that we need some kind of load on the secondary of the transformer now, because the output tubes are installed. And if we do not load down the transformer, we potentially could have very, very high voltages, too high for the transformer on that secondary. So I have a little dummy load here. It doesn't 300 watts, 8 ohm. I believe with a wire wound resistor, just with a little 1/4 inch plug on it. So we're going to put this on, and we're going to put the output tubes in, and then fire the amp back up again. Oh yeah, here's our output tubes. These are Hammond Mark 7591. That font to me looks like Sylvania's, but maybe some other people would know better. But yeah, we got a pair of these, and these are the original tubes from the original amplifier. So popping them back in. All right, so I got the output tubes installed. We got the 8 ohm load on the secondary of the output transformer. You can see our voltage is climbing back up. It's a bit of capacitor. I think it's called like capacitor memory. Your voltage will rise. This can actually get up to somewhat dangerous voltages, so be aware of that. So we're ready to turn back on the amp. We still got the bulb limiter in series. So now we're going to be checking voltages around the output section and make sure everything is all good there. So let's kick it on. Variac, confirm we're starting at 0 volts. Bulb limiter's on, power switch is on. All right, let's give it some voltage. We'll come up to half voltage again. So even more current draw now that we have 2 output stage tube heaters to warm up. Also another thing, I wound the bias supply potentiometer. I wound that all the way to max resistance for that tail going to ground, so that we have the maximum negative voltage going into the grid, which will turn off the tubes as hard as possible for the circuit, basically to give us the best chance of avoiding red plating. The tubes should be too cold in this setting. We should have to reduce the shunt resistance for the bias supply in order to get appropriate operating conditions for the tube, which is about 60 to 70% of plate dissipation. Okay, we leveled out here around 262 on the plates for the output tubes. Got 59 volts AC coming from the wall. Let's check our screens. There's the screen, 245. What did we say our plate was, 260? Yeah, so screens are a little lower than the plates, which is totally normal. Here's the other tube plate. About the same, it's good. And screen is 245, cool. So that's all normal. Let's check, where's our bias coming in? Here's our bias, it should be negative, yeah, 16. So about negative, half of negative 32, which is our expected minimum bias voltage. And might have a little bit of voltage here. Nope, still nothing detectable on these shunt resistors. Okay, so all that looks good. Let's go back on the plates. Also, forgot to mention, we'll do it now. You want to turn down your volume for the amplifier. Turn down your preamp volume, reverb volume. Turn all that stuff down. Tone controls just leave in the middle. All right, so next up, we're going to power this sucker up to full wall voltage. You might expect to see a little bit of glow out of the bulb limiter here. I'm going to stop there for a second. That's 110 volts. Just pop over to, just want to check and make sure that that 450 volt cap, yeah, 260. Okay, cool. No problems there. Let's go back on the plate. Okay. Oh, got to check the lamp. Is the lamp turned on? I can't tell if that lamp's on or not. Oh, I know why. The lamp strikes on around like 80 or 90 volts, I think, this one, and we're being limited. All right, so we're at full voltage with the output tubes in there. 480 volts on the plates. Let's check the screens. Not much current flowing through the tubes. We can see that rise if we adjust the bias supply here. Turn that, we should start to see. Yep, here's the current coming up through the tubes. Oh, that was interesting. Whoa, okay. We might have our negative feedback wired incorrectly, which means we have to swap the plates for the tubes. So we will check on that. All right, so I was getting some low frequency oscillation coming out of the output section, and so I reversed the plates of the output tubes in order to turn that negative feedback, or that was actually, it was positive feedback, into negative feedback. So let's give it another go and see what happens. All I did was swap the wires for the plates of the output tubes, so hopefully didn't create any shorts in the meantime. All right, there's 119 volts on the Variac. And the probe here is on the current sense resistor on the output of this right output tube, middle tube there. Our current draw is 0.38 amps, which is 380 milliamps, which is two very cold 7591s. Let's turn up the bias supply, or I guess make the bias supply more positive, and we should see the current increase through the tubes. Yep. So obviously we're limited by the bulb limiter still, so, but our current is increasing. This is increasing steadily, so all that looks good. The oscillations are gone. Plates at 435. Screens at 362. There's the other plate, 430. Okay. Cool. It's 0.8 milliamps through that tube. This tube. Come on. 12. So tubes aren't exceptionally well matched. This one over here is the hotter tube. I'm going to swap those tubes just because it's easier to clamp on to this tube. But everything looks good. Amp is stable as far as current draw. So let's wind our bias supply back down, and we are ready now that we're almost certain that there's no shorts in the amp. We're ready to take it off the bulb limiter and check all our voltages again. All right, so we're back. Same setup, except bulb limiter is removed from the circuit. Let's turn our amp back on here. Now's a good time to whip out your favorite tube bias calculator. Shout out to Rob Robinette. Their bias calculator is a good one. That's what I'm going to use. So we have tube type is 7591s. Oh yeah, I think something with the Rob bias calc. 7591 is shown as a 15 watt tube, but if I recall correctly, 7591 is actually a 19 watt tube. 7591 data sheet. Max plate dissipation is 19 watts for a 7591. So note to anyone using Rob's bias calc 7591, it's not a 15-watt tube, it is a 19-watt tube. The way this works is you put in your plate to cathode voltage. This is a fixed bias amp, so that's just your plate voltage, which right now is 278. So currently, right now, if this was the amp we're working on for Class AB fixed bias, if you wanted 60%, it would be 41 milliamps of current going through the tube. Let's see. If you wanted 70%, it would be 47 milliamps. But our voltage is going to increase significantly, so let's do that. Let's bring it up here. All right, we're at 117 on the wall, 487 on the plates. Let's put that into our calculator. 60% will be 23 milliamps. That's what we're shooting for. We're at 16. Gonna check that other current sense resistor. This was the lower tube. Yeah, these tubes are not particularly well balanced. Okay. All right, so the problem we're having right now is I can't actually turn the bias supply down enough to get 60%, which means the fixed resistor I have at the end of the bias supply is too large. So we're gonna have to drop that down. It's a 5.6K, we'll drop it to a 4.7K, and then we'll come right back. All right, so like I said, I wasn't able to increase the bias voltage enough to allow enough current to flow through the tubes. So I had to adjust the fixed resistor in the bias supply. This one here, this 5.6K resistor. I started with a 4.7, I still wasn't able to go low enough, so I'm down to a 3.3K now. It should be known that when you do this, you are going to adjust how the bias potentiometer works, because now that 10K potentiometer makes up a greater percentage of that entire shunt resistance. So now, by reducing that fixed little resistor, the bias supply is less fine. I get more change for a given, like, a change of angle in the potentiometer. Anyway, let's power this up, hopefully for the last time. And then once we're good, we'll be able to plug in a speaker and a guitar and see what happens. The probe is on the current sense resistor for the left output tube here, which is the hotter tube. And we're just easing our way into it so we don't exceed any voltages. 480 should be good enough to go to wall voltage here, 120 volts. All right, we got 120 volts AC. We're at 494 on the plates. A little bit low on the bias, so we're going to adjust the bias down or up in voltage. Yeah, 22, 23. All right, there's 23 milliamps on that tube. This tube is lower, right? Yeah, this tube's at 18. Plate voltage is at 488. Class AB fixed bias, 23.5 milliamps is 60%. And we're at 23. So now I would say the amp is biased. So feel pretty good about that. Looks pretty stable so far. We are going to go to the next step, which is making some noise. All right, so here is the last quote-unquote test. I've got a 8-ohm speaker cab hooked up. I've got my guitar plugged in. Volume is down. Tone controls are in the middle. Dwell is down. Reverb volume is down. Reverb switch is set to on, so reverb's in circuit. Got the reverb tank back here, plugged in. So we're ready to just throw the switch and see what the heck happens. Hold on to your hats. And we have sound. Don't want to kill the mics. See if that reverb's working. Yep. Give it a little more. Oh boy, there's a lot of reverb. Let's see, we're right around noon on both. Oh yeah. I can't stand reverbs that are too subtle. This is a real reverb. A little more bass, a little less high. The guitar I'm playing doesn't have a tone control, so it's just pick up straight to jack, so it's there's a lot of high end coming through. Okay, so I would now consider this amp operational. I'm going to let it sit here, play it a little bit more, just make sure it's stable. And then after that, we'll do a proper miking up of the cabinet so you can have a real listen to it. But yeah, amp is done. Well, as done as any amp can be, really. When you got a soldering iron, no amp is ever done. All right, time for a real listening test. So I have a 1x12 cab hooked up. I've got a SM57 on the cone, 120 volts on the Variac. Got the amp faced the right way up. Reverb tank still just sitting on the table. Another quirk that I thought might be the case, but now confirmed is the case, is that the bass and treble controls are reversed. So you turn it down for more bass, turn it up for less bass, or like cut controls. I could spend, a half hour, an hour fixing that wiring, making it so they work like normal. But it's my amp, and I kind of like it. I kind of like it's a little bit chaotic, a little bit just, letting the universe play out. Yeah, so I'm going to keep it that way, at least for now. So yeah, let's not waste any time. Let's fire her up. Yeah, so there we go. That is the amp. I'm really happy with how it sounds. I think I'm going to keep it the way it is for now. Just keep on playing it, getting a feel for it. But yeah, really satisfied with that. Yeah. All right, so here it is, the final product. Got the amp mounted in a head shell now. Got the reverb tank mounted in there as well. I hope you enjoyed this video. Hope you enjoyed the series. If you missed any of the episodes, feel free to head back and watch those. If you enjoyed this video, I'd appreciate you hitting the like button. And also hit the subscribe button and the notification bell. Because I plan to put out a video every Sunday, and I have some cool videos coming up. So, my name is Joe from Great Bench Electronics. Thank you for watching.